Hi guys, Buildzoid here, and so today I just want to talk a little bit about this here 980 Ti Kingpin Edition, because this is one of the few cards that I've actually managed to successfully repair. um, yeah, so I figured I'd talk about it. It's not my card, unfortunately. That's the sad part. It's a card. This card belongs to a longtime supporter of the channel. He picked it up off of eBay as dead, which I totally support that. Where do you think I got this? Yeah. So anyway, but he picked this up on eBay. It was dead, and he was talking about troubleshooting it on Discord, and I was like, and basically he said that the main thing is, and this is still broken on the card, there's a bunch of LEDs up here to indicate that the various voltage rails on the card are running. And basically he said, oh, that's not working. It looks like the card isn't getting VCore, PLL, whatever, right? Various minor voltage rails on the card apparently not working. So I was like, okay, well, that should be relatively repairable. Much more repairable than what I got when I bought this thing, because when I bought this thing, the reason why it doesn't have a core is because the core was literally multiple pieces. Like, the silicon was shattered. So that's not something you repair. That's something, like, you need a new core. The only place you get new cores is other 980 Ti's or Titans or whatever. So, and I don't currently have the equipment or the skills to do a full, proper BGA replacement. Well, I do want to be able to do that, so I'm just gonna kind of sit, like, I'm fully, I'm happy to just sit on this thing until I work my way up towards being able to finally put a new core on this, right? It's gonna be a nice payoff in maybe a couple years. At the rate my soldering skills are improving, yeah, a couple years is probably a realistic time frame for me to actually successfully fixing that, but, you know, it's not like this is gonna run away from me. So, yeah. Anyway, this card, on the other hand, like, no voltages, so that should be relatively easy to fix. So I offered to just kind of repair the card for free because it's a 980 Ti KPE, and I'm like, I will repair 980 Ti KPEs for free. that is just a very simple sort of. There's not that many of these. They're not super exclusive, but I do believe there are only a couple thousand units of these that ever got made. So, you know, as far as I'm concerned, I want to repair one of these for the sake of repairing one of these more so than I care about sort of repairing something for somebody. It's like I just want more working 980 Ti KPEs to exist. That's essentially the motivations behind me fixing this thing. Anyway, so I offered to fix it. And I did fix it. It does work. The LEDs don't, but the card does. So the thing that killed the card is actually the thing that's missing on my card, because ultimately, like, I didn't need to steal this for my card. It's just that troubleshooting the card was actually a massive pain. So basically, this missing part down here, this is a linear regulator, and it's an APL 1117. Yep, APL 1117. And the problem was basically, well, I still don't get why that regulator even exists. There's three 3.3 volt regulators in this area of the card. Like, this right here is a 3.3 volt regulator. That's another 3.3 volt regulator. That's another 3.3 volt regulator. Why does a card that has a 3.3 volt source on the PCIe slot need three linear regulators to convert 12 volts into 3.3 volts? I have no idea, but it does. Like, EVGA decided that yeah, they're gonna give it 3.3 volt regulators. Anyway, so the troubleshooting process for any GPU is very simple, especially when, you know, it's like, oh, there's a voltage rail missing. You basically just like, I have a temporary heatsink that is basically just a block of aluminum with some heat pipes in it that I stole off of a GTX 680 that I killed. So, not really stole, but I killed that GTX 680 with two thick thermal pads. So it wasn't even like a cool death. It was like I literally just reassembled it with thermal pads that were a bit too thick. Forced the freaking piece, like, forced the heatsink on anyway, which bent the PCB, and goodbye card. So that's kind of that. Yeah, do not use overly thick thermal pads. If you use way too thick thermal pads, you're gonna kill GPUs very, very quickly, because if you flex like the BGA or something, you're potentially just going to rip solder balls right out of the PCB or out of the substrate, either one, right? Like, something's going to give up. So yeah, don't don't bend PCBs unnecessarily, right? Like, try to avoid that as much as possible. So anyway, but because of that, I do have a heatsink that I can sort of just mount to cards, and it takes up essentially just the area around the chip and over the memory chips. So then I can still, stab a lot of various regulators around the card with a multimeter. And then, so that's what I did initially, and I checked like VCore was present, memory was present, this regulator, which I don't know what it is, that was present, this down here, which is PLL, that was present. This runs, which that is actually power for the VRM, so of course that runs, because if the VRM runs, then that has to run. This is some random regulator that I have no idea what it's for. It sits at about the same voltage level as the PLL voltage, which is just like I think it's a 1.05 volt regulator. That's 1.05 volts. That's another 1.05 volts. These aren't connected. I actually checked that, so there is a lot of random sort of voltage rails on this card where it's like, wait a minute. I'm pretty sure these are not supposed to be separate regulators on I don't think these would be separate rails on a 980 Ti reference card, but it's a KPE, so maybe that's part of what makes these so great on LN2. There's a regulator up here, which I can't remember what that one's for. And then we have this array of 3.3 volt regulators over here. And so I went around the card just kind of stabbing everything that looks like a regulator. So if there's an inductor, you want to stab it, because inductors indicate either they're for input filtering or they're for a buck converter. There's not really much else they're going to be used for. So stab every single inductor to get a voltage reading. Stab every single thing that looks like a linear regulator. Now, linear regulators come in lots of different packages, but basically this sort of MOSFET package with the, that right there is a common, that's you can get old style MOSFETs in that, but you can also get, I call them old style MOSFETs, but you can get, even now you can get new MOSFETs in that. It's just that's a MOSFET package. It's also really popular for linear regulators. These 8-legged things that I don't know the name of, I don't know the package name. Those are also often linear regulators. They can also be BIOS chips. So that's the other thing, is you can have BIOS chips in that package as well. But anyway, so I went around the card, not this one, this one. And I noticed that this regulator down here, when you turn the card on, it would initially jump up to 1.8 volts. And then it would slowly drift down to around 0.9, and then it would sort of hover around 0.9, but not really. It looked like it was shorted out or something, right? It looked like the regulator was not regulating as it's supposed to be, because the voltage level was kind of floating all over the place, and that was very, very strange. So then if you turned off the card, then the voltage actually would just shoot right up. It would go up to a little over 2 volts, and I was like, okay, so obviously that's supposed to be maybe a 2.5, maybe 1.8 volt, maybe, something other than 0.9 volts, because that thing obviously at startup, it's not at 0.9. After turn off, as you turn it off, it's not at 0.9. So it's not supposed to be at 0.9. It's obviously having some kind of issue. I checked the rail, I checked the resistance on the output of it. No short circuit. It's kilo ohms or something. I think it was several hundred ohms or kilo ohms even in terms of resistance range. So obviously no short circuit. So then I was like, okay, so probably it's just the regulator's got to be dead, because I can't find, it's a very simple circuit. There's no missing components. There's not really any components to be missing. There's essentially 2 resistors, because it's a that regulator is actually made into a bunch of different flavors. You can get it in fixed output voltages, or you can get it in a variable output voltage. And the one here was variable output voltage, for some reason still configured for 3.3 volts, even though you can just buy a 3.3 volt version directly from the manufacturer. But I guess it's just convenience, where EVGA just uses the configurable one on multiple different products. So they just use one size fits all, and then for each product they just change the resistor configuration, which is probably that's going to be cheaper than having a 3.3 volt part and a 1.8 volt part, right? You just buy the adjustable version, and the PCB sets the actual final voltage. But anyway, so obviously this thing was not running the way it was supposed to, and so I grabbed another one of those. So I looked up the data sheet for the chip. That's where I figured out that there's actually a bunch of different flavors, and that this one, the one EVGA is using, is variable. So then I checked the resistors on the PCB, and I was like, oh, so this would probably be set to about 2.5 volts. At least that's what it looked like to me. Apparently it's actually set to 3.3 volts, so I must have done the math wrong, which wouldn't surprise me, because I'm really good at screwing up basic math. So Yeah, and then not noticing for like a very long time until then I go back and go like, oh yeah, why is this number here? Anyway, my math skills aside, basically I miscalculated. I grabbed now I've been sort of started basically scrapping a lot of the cards that I have that are dead for spare parts. So I had to pull MOSFETs, regulators, all kinds of things. So I figured I'm pretty sure I've already pulled off an APL 1117 linear regulator, adjustable linear regulator off of something before. So I went through my collection of like junked parts and I was like, oh, this is the actual regulator. So I swapped that one onto the card and the voltage was 3.3 volts. And I was like, oh my God, I screwed up because my calculation said it was supposed to be 2.5 volts. It went up to 3.3 volts. The card still wasn't working because idiot me was testing it in a motherboard that I can't tell you about. And that motherboard just isn't compatible with the GPU, which, like, so even if the card was working, it wouldn't boot in that on that motherboard. I absolutely love how that's possible. You'd think PCIe is standardized, right? Like, no. Anyway, so it doesn't boot on the bloody board. And it's not even a PCIe 4.0 board. It's the 3.0. So it's not like it was out of spec or anything. It was just like BIOS doesn't know how to initialize the card. So, it goes up to 3.3 volts. The LEDs still aren't working. The card still doesn't display an image. The motherboard doesn't see the card. And I'm just like, oh my God, I really screwed up. That's not the adjustable regulator. So I pull that one off. I go and grab my card because at the time mine was just missing the core, and I pull the APL 117 off of mine and put that onto the card I'm actually, this lovely card right here. And so I put that one on, and it's still 3.3 volts. And at that point, I'm just like, what? So, yeah. And so then I spent just forever stabbing it with a multimeter, just going in circles, essentially. Like, I'd check vCore, I'd check memory, I'd check PLL, I'd check the other thing that looks like it's probably PLL, and then the linear regulator that looks like it might also be PLL. And then various 3.3 volt regulators, and I'd be just like, why isn't it working? There's like everything that looks like it should be regulating a voltage is regulating a voltage. Why does it not work? And then eventually, after several hours and, feeling really bad about myself, I got the genius idea, which was actually genius, to move the card from a CPU PCIe slot to a chipset PCIe slot because, and this is true with other cards as well, if you want to run like a GTX 590 on Z390, on most Z390 motherboards, a GTX 590, if you plug it into a CPU PCIe slot, will not initialize because for whatever reason, the motherboard vendors didn't bother to implement like support for the PLX chips. But if you plug in that same GTX 590 into the chipset PCIe slot, the chipset, for some reason, is able to initialize the card. So evidently, Intel is better at backwards compatibility than all of their motherboard partners because I've run into that issue with basically every single Z390 motherboard I have. So if I want to run a GTX 590 on Z390, use a chipset, like you have to use a chipset PCIe slot, which sucks for performance because that's an X4 PCIe slot. But, not really, at least the card bloody runs, which is sort of the priority. Anyway, so I moved this onto the chipset, and it ran, right? Immediately, like, it initialized, it had output image, and I was like, well, it's good that I fixed it. It didn't need the APL off of mine, so that first APL I swapped onto there was correct. That was actually the correct part to use. So I didn't get that wrong, so I'm not that stupid. The thing is, there's a labeling code to tell you if the part is adjustable or not, and it's like, this looks like the adjustable labeling code, so I was right about that. It was the correct part. It's just I was trying to initialize the card on a motherboard that can't initialize the card. I've come to the conclusion that if I'm ever trying to repair a GPU in the future, I'm probably gonna run it on like frickin' some DDR3 platform, because that is far more likely to be able to initialize a GPU than modern platforms, in my experience. Like, the more modern something is, the less GPUs work in it, which is not fun. Anyway, so I got the card up and running. I ran several hours of 3D Mark Firestrike. The funny thing is, the LEDs still don't work. So this card, like, those LEDs are there to indicate that the GPU is functional. The only part of the card that, as far as I can tell, doesn't work is the part that tells you that it's functional. On the other hand, this thing, LEDs work, which they should because all the voltage regulators work. The reason why I haven't fixed the LED functionality on this card is basically because those LEDs are implemented with what looks like a massive array of discrete transistors. And there's no way I'm trying to like figure out how all of those are connected. Like, this is a multi-layer PCB. There's like there's definitely more than one transistor per LED. I don't know where they go. I don't know which one corresponds with which LED. Like, without a schematic, it's a lost cause as far as I'm concerned. Like, I'm not gonna go and, compare, like, because basically what I could try to do is, like, measure something on this card, then measure the same place on the other card and see if, like, there's a voltage level mismatch, and it's just, like, that's going to take forever, so, this card can think it's dead as much as it likes, but at the end of the day, it does indeed run, and I will actually demonstrate that it does actually start. Let me just plug it in. Come here. And I'm doing this on an X570 motherboard, which is a dumb idea, because I don't actually know if it works on X570. I know it works on I had it working on a Z390 board, which I guess at that point I've given away what platform it is that it doesn't work on. We do need power cables. Do I have power cables? Of course. Yeah. So. Yay, the tiny desk is... Well, it's not a tiny desk, it's just like I have too much stuff on it. That's the main issue. Okay. Now the thing is, you do actually need to plug into these cards, you need to plug in at least the two 8-pins. And then a 6, and well, I can plug in a 6-pin because that's off of a daisy chain, so I'm just going to plug all of that in. And hopefully this starts. Yeah, and you can see, the LEDs up there, not working. Or more like you can't see them, but they ain't working. Oh, don't tell me this is another one of those boards that can't start this card. Oh, no, it worked. Yay, it worked. That green LED tells you that See? So, yeah, works. Awesome. So at least it works on X570. So now you know that I didn't try to test it on an X570 board. I hate how modern platforms are just like all over the place with support. Anyway, so let's power that off. And now I'll swap in the card with the missing core just to show you that the LEDs that aren't working. So the LEDs on this don't work. And I'll just show you what they're supposed to look like when they do work. Because, man, ITX boards. Okay. So let's plug that in. And we can actually just start it like this because the way Nvidia GPUs are unnecessarily complicated, so actually if you don't have the power connectors plugged in, the card is still capable, like it'll just pull 12 volts and 3.3 volts and feed that into the VRM instead. Like, I don't know why they bother. If you did this with an AMD card, half the VRM won't have power, or actually depending on which AMD card you do this with, the VRM won't have any power and it can't turn on because there's no power to turn on with. But anyway, so I need to put my finger there so you can see the LEDs. See? So that white light indicates that the LEDs are working. And those LEDs on the other card, they're very much not working. But the card works, so I don't care that the LEDs don't work. Because the LEDs are kind of like... Yeah, like the LEDs ultimately... They're there to tell you if the card is broken or not. But if the LEDs are broken, then... that doesn't stop the card from working. So, yeah, just wanted to do a little video about that. Because... well, I spent way too much time trying to repair the damn thing to not get a video out of it. Especially since I decided to do the repair for free. So it's now like, now I'll get my AdSense for that. Yeah. So, just needed this regulator down here. And then not using use a motherboard that actually, you just need a selection of motherboards, because I think you'd potentially you could run into the same issue if you use a too old motherboard, where if you had like a GPU that only had like I'm not sure this would actually happen, but because there's like legacy GPU BIOS and UEFI GPU BIOS, and Though that still should not be an issue on a GTX 980 Ti. I have no idea why this doesn't initialize in the board that I tried using it on. So yeah, I'm still really confused about how that happened. Because like on AMD GPUs, especially if you'd like mod the BIOSes or something, they won't be like UEFI boot compatible anymore, and you have to boot them in legacy mode. And I have run into issues with that on some Asus boards as well, where I have to boot with like a GT 710, set the BIOS to legacy mode, then I can boot my modified AMD GPUs. But yeah, with the 980 Ti, that should not be a problem as far as I know. Especially since it's not like the BIOSes on these are modded. But yeah, card now works, which is a good thing, because I was really worried I'd killed it. when that regulator went up to 3.3 volts, because the thing is, it doesn't even make sense why there's three 3.3 volt regulators. Like, I still don't get it, because they're dumb. They don't have, like, there's no, as far as I can tell, there's no, like, enable circuitry for them. So it's not like you could disable them in the case of a malfunction. But there's, and you can get 3.3 volts from the PCIe slot, right? So it's like, well, if you wanted a dumb source of 3.3 volts, there's one right here. Why is there 3 regulators on the card in this area for that? I have no idea. But yeah, at least the thing works. So I just kind of wanted to talk about that, because it's not very often that I actually manage to repair GPUs. So yeah, and I'll probably do some benchmarking with this card before I end up sending it back, because like the actual owner of the card said it would be okay to take it on liquid nitrogen, but I'm happy that this damn thing just runs at this point. So if it, like, I'm not taking it on liquid nitrogen, because I don't want to be sending it back. Like, I want it to be leaving in a better condition than it came in at, right? So, yeah. Anyway, so hopefully you found this somewhat interesting, because, yeah, it's a pretty random video. Yeah, so thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. That'll over time that'll eventually get a core onto this thing. So yeah, if you want this card to have a core someday, there's a Patreon, link down in the description. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. That achieves the exact same thing. Maybe if maybe someday I'll have the equipment to replace the core on this. Which I'm not actually going to buy like a proper BGA station. I'm just going to put together something to do not terrible BGA work. And I won't use it on this first, because that's a terrible idea. I'll like, because the thing is, I have a bunch of like old cards with small cores, and I want to do like, basically I already have a plan to like work up to it, is like do memory chips on memory sticks first, because memory sticks are easy because they don't have a lot of mass. Then move on to like little GPUs, then bigger GPUs, then giant GPUs. This is very much a very big well, actually, with some of the HBM stuff coming out these days, we might have, like, I can't really call this a giant GPU, right? But yeah, so that is it for the video. Thanks for watching. Like, share, subscribe, and I don't need to redo my outro, so I'll just hit the stop button at this point. Goodbye.